Hey guys, welcome to Notes on Logarithms. These are like exponentials. In fact, everything we've discussed has had an inverse. Addition and subtraction will undo each other. Multiplication and division are inverses. Square root and squared are inverses. The inverse of an exponential is a logarithm. And that's what we're going to talk about today, logarithms. They're the inverse of the exponentials we talked about last time. So what's a logarithm? A logarithm, which I'm just going to call a log, is the inverse of an exponential function. It's how we get the x out of the exponent. Just like there are many different radicals, squared, cubed, and there are many different logs, so there are different bases. So here's an example of a log. The log of 8 base 2 is equal to 3. Or you could say the log base 2 of 8 is equal to 3. So it's got a base, a log, and an answer. How do we convert between logs and exponentials? My mind, and yours probably too, will never naturally think in logs. However, you're pretty good at thinking in powers. So let's convert logs into exponential problems and see if they're any easier to solve. So, how do I convert log of 81 base 3 equals 4 into an exponential problem? Well, the base is 3, the answer is now the exponent, and the log is now your answer. 3 to the 4th is 81. And yeah, that's easy to see. 3 to the 4th is 81. The general rule is that the base is the base. The answer, oh, this is wrong, sorry. The base is the base. The answer is now your exponent, and your log is now your answer. So let's try to convert these to exponential form and then solve. Well, base is 4. The answer is now the exponent. The log is now the answer. 4 to what power equals 16? 4 to the second power is 16, 4 squared. How about over here? This is 64 to the x is equal to 8. Well, what can I do to 64 to get 8? I'm going to do a square root. But what a square root is what power? A square root is a 1/2 power. So x equals 1/2. What power is a cubed root? It's a 1/3 power. What power is a 4th root? A 1/4 power. Some famous logs. There's 2 famous logs that we talk about. Since a log can have any base, how does a calculator do a log? Well, it only does 2 different ones. Base 10 and base e. Base 10 is called a common log. You don't even need the 10. So if you ever just see a log, that means base 10. Why do you think base 10 is the common thing we count by? 10 fingers. So use your calculator if we need to. We're not going to need to. Let's rewrite this as an exponential. The base is 10. I don't know the answer, but the log is now the new answer. So 10 to what power is 100? 10 squared. Over here, 10 to what power is 0.0001? Well, if you've had scientific notation in your science classes, you know this just means to move the decimal. So I took 10 and I moved the decimal 1, 2, 3, 4, 5. So I moved the decimal to the left 5. Answer, -5. No, I'm sorry, it's -4. Because this is 10 to the first, 10 to nothing, 10 to the -1, 10 to the -2, -3, and -4. An easy way to do it would be to count the number of places there. Negative. What in the world is e? I said base e was another common form. E is an irrational number. It's like pi. Decimals never repeat or end. It's about 2.71828182845904523. So why would I ever use e in the real world? Well, when you take my calculus class in 2 years, you'll find out. Until then, just know it's a really common growth ratio. A log with base e is called a natural log, and it's one of the most important logs we use. Log base e, we write ln of x. Now that's natural log. Even though it's ln, we say it's natural log. Plugging other logs into a calculator. The only logs that a calculator can do are common log and natural log. However, most problems aren't common log or natural log. We need to convert different logs into either common log or natural log. Luckily, there's a formula. I take log base b of a is log a over log b, or natural log of a over natural log of b. It's log of the big one divided by log of the base. Let's find log of 128 base 8 using both common log and natural log. So, log of 128 divided by log of 8. 2.333 repeating, or 7/3. Now let's do the same thing with natural log. Natural log of 128 divided by natural log of 8. Hey look, I get the same answer again. I get 7/3 again. So the answer is 7/3. So if you need to convert, you don't know how to do it, that's an easy way to do it in the calculator. Log properties. These are by far the most important part of this section, and it's what we're going to spend the next couple days in class doing. The sooner you memorize these, the better next year will be for you. Any log of 1 is 0. So log of 1 is 0. If the base and the log are equal, they cancel each other out and they just make 1. 2 logs added is 1 log multiplied. 2 logs subtracted is 1 log divided. Or the way I think about it is positive log on top, negative log on bottom. If there's an exponent, put the exponent in front of the log. And that's the most important thing, because now I took an exponent and I turned it into a multiplication problem. Let's expand a log. That means to write 1 log in as many different log rules as possible. So I have a log of 3 things. So I want 3 different logs. What are my 3 things? They're 2, they're x, and they're y. Well, what are the 2 and the x doing to each other? They're multiplying. 1 log multiplied is 2 logs added. What's the y doing? It's dividing. 1 log divided is 2 logs subtracted. How about down here? Even though it's natural log, it's the same thing. How many logs do I have? I have 4, natural log of A, 5, natural log of A, natural log of B, natural log of C. What's the 5 and the A doing to each other? They're multiplying, so I add them. What's the A and the B doing? They're multiplying, so I add them. But the B had a squared. What do we do with exponents? We put them in front of the log. The C is dividing, so I subtract it. But the C had an exponent. A cubed root is a 1/3 power, and I put it in front. We are going to spend a lot of time on this in class, so don't panic yet. That's expanding. That's taking 1 log and writing it in as many different logs as you can. Let's go the other way. Compressing. Taking as many logs and writing them as 1 log. If it's a positive log, I'm going to put it on top. If it's a negative log, I'm going to put it on bottom. X is a positive log, it goes on top. Z is a positive log, it goes on top. The 1/2 is going to come in and be a 1/2 power. But what's another way to say 1/2 power? Square root. The y is a negative log, it goes on bottom. But the 2's got to come in as a power, so it's y squared. That's called compressing. Let's do the same thing down here. The x is a positive log, it goes on top. The 5 comes in as its power. The y is a negative log, it goes on bottom. The 3 comes in as its power. The a is a negative log, it's on bottom. A 1/4 power is the same thing as a 4th root. And then this x is on bottom because it's negative, and it's a second power. But we wouldn't leave this with two different x's in there. I would rewrite that as natural log of x to the fifth over x squared is x cubed over y cubed 4th root of a. That's called compressing, following your rules to make 1 log. I know that's a lot to throw at you in one time, and it's just in 10 minutes. But we're going to do a lot of practice in class on that. This is just an overview. So if you have any questions, come talk to me. Thanks.